Before anything lived, before anything could move, before the idea of life had even learned how to begin, there was time. Not the time we know now, not measured in seconds or days or years. This was a deeper time, a slower time, a time so vast and quiet that nothing marked its passing. No footsteps, no breath, no beating heart, only change unfolding so slowly that even change itself seemed asleep. Tonight, we travel into that silence. We are going back more than 4 billion years to a world that does not resemble the Earth you know. A world without animals, without plants, without sound. A world that exists but does not yet experience itself. This is Earth before life awoke. At first there is darkness, not the darkness of night, but the darkness of absence. No sky, no horizon, no familiar shape. Just a growing planet forming quietly from dust and fire, drawn together by gravity in the endless cold of space. Bit by bit, grain by grain, Earth assembles itself. The newborn planet is violent but not angry. There is no intention here, no purpose, only physics repeating itself endlessly. Heat builds, pressure grows, the surface is not solid but molten, an ocean of glowing rock, slowly churning, slowly cooling. Above it, space presses close. The moon has not yet settled into its gentle orbit. The sun burns younger and dimmer, a pale star compared to what it will become. Days pass quickly now. A single rotation lasts only a few hours. Earth spins fast, restless, as if it has not yet learned how to slow down. Meteorites rain from the sky again and again and again. There is no atmosphere to protect the surface, no shield to soften the impacts. Each collision reshapes the planet, carving scars that will never be remembered because there is nothing here to remember them. For millions of years, this continues. Heat rises from below, impacts fall from above, the planet glows, and still. Nothing lives. Eventually, almost imperceptibly, Earth begins to cool. The surface hardens in places, forming thin crusts that crack and melt again. Volcanoes open and close like slow breaths, releasing gases trapped deep within the planet's interior. Carbon dioxide, methane, water vapor, ammonia, sulfur. These gases drift upward, lingering close to the surface. An atmosphere begins to form, not a sky, not yet, but a heavy, choking veil clinging tightly to the planet. There is no oxygen. Nothing could breathe even if it tried. The sky, if it could be seen, would not be blue. It would be thick and hazy, tinted orange or red by chemical haze and volcanic ash. Light from the sun struggles to pass through, dim and scattered. Below, the ground is still hot, still unstable, still changing. Time continues. Millions of years blur together without distinction. No seasons pass, no cycles repeat, nothing marks the rhythm of existence. The planet simply is. Then, slowly, something new happens. As Earth cools further, the water vapor in the atmosphere begins to condense. At first there are clouds, dense, heavy, unfamiliar. They gather and thicken. They drift across the planet, carried by winds that have never brushed against leaves or feathers or skin. And then rain, not a gentle rain, not a passing shower, but rainfall that lasts for centuries, for millennia, for spans of time longer than human civilization will ever exist. Water pours down onto the barren surface. It fills low places, it gathers in basins, it flows across naked rock, carving channels that will later be erased and then carved again. The oceans are born, vast, dark, and empty. They stretch across the planet, covering most of its surface. They are warm, sometimes nearly boiling in places, and chemically rich, filled with dissolved minerals and gases, but they are lifeless. No fish swim beneath the surface. No algae bloom in the shallows, no coral builds silent cities. The waves rise and fall against empty shores again and again for hundreds of millions of years. The sound of water exists, but there is nothing to hear it. Above the oceans, the sky remains toxic. The air is thick with gases that would suffocate any future creature. Lightning flashes often, striking the surface, cracking the air with energy. Each bolt delivers raw power into the planet, rearranging molecules, breaking bonds, creating new ones. Chemistry is everywhere, yet life still does not exist. This period will stretch on for an almost unimaginable length of time. 1 billion years, 1,000 million years with no animals, no movement driven by desire, no hunger, no fear, no awareness. Earth is alive in motion but not alive in mind. And yet the stage is being prepared. In the oceans, molecules drift, they collide, they separate, they combine again, over and over. An endless experiment conducted by time itself. Some molecules begin to form more complex structures. Simple chains, simple patterns, nothing that thinks, nothing that wants, but something that lasts a little longer than the rest. These patterns repeat. Energy flows through them from sunlight, from lightning, from heat rising from the planet's interior. Some structures persist, others fall apart. There is no intention here, only chance filtered by stability. Slowly, incredibly slowly, chemistry begins to favor repetition. There is no single moment where life begins. No sudden spark that announces its arrival. Instead, there is a gradual leaning toward complexity, a quiet preference for patterns that can maintain themselves. Time passes, hundreds of millions of years. The oceans churn gently. Tides rise and fall under the pull of a moon that now hangs closer in the sky, larger and brighter than it will ever appear again. Volcanoes continue to release gases, renewing the atmosphere again and again. The planet breathes in fire and exhales clouds. Still, there are no animals. No eyes to see the sun, no ears to hear the thunder, no nervous systems to feel heat or cold. Earth exists in total anonymity. Eventually, somewhere in the oceans, perhaps near hydrothermal vents, perhaps in warm tidal pools, something changes, not dramatically, not suddenly. A chemical system begins to copy itself. It does not know what it is doing. It does not plan. It does not think. It simply persists. When conditions are right, it makes another version of itself. This is not life as we imagine it. There is no cell, no membrane, no DNA in the modern sense, just chemistry that remembers its own shape. Over time, this remembering becomes more reliable. Boundaries form, tiny compartments, primitive membranes that separate inside from outside. Within them, reactions happen more easily, more predictably. The first true cells emerge. They are microscopic, fragile, invisible to anything but the laws of physics that govern them. They drift in the oceans, unaware of the planet they inhabit. These cells do not eat, they do not hunt, they do not move with purpose. They absorb energy from their surroundings and use it to maintain themselves. They reproduce slowly, and they change almost imperceptibly over countless generations. This is life, but it is life without experience. For hundreds of millions of years, Earth will be ruled entirely by such organisms. Single-celled life, bacteria, microbes. Forms so simple that calling them beings feels almost too generous. They blanket the oceans. They form thin films on rocks. They cluster in mats along shallow shorelines. Some of them learn to harness sunlight. They use it to power their chemistry, releasing a waste product into the ocean and air. That waste product is oxygen. At first, oxygen is rare. It dissolves quickly into the oceans, binding with iron and other elements. It rusts the planet from the inside out, creating layers of iron-rich rock that settle on the seafloor. For a long time, oxygen never reaches the sky. But the microbes persist, they multiply. They continue releasing oxygen molecule by molecule, day after day, century after century, million after million years. Slowly, the planet begins to change. The oceans can no longer absorb all the oxygen being produced. The iron becomes saturated, the chemical sinks fill, and at last, oxygen begins to escape into the atmosphere. This moment will later be called a catastrophe. For most existing life, oxygen is poison. It damages their chemistry. It destroys the fragile balance that has kept them alive for eons. A mass extinction unfolds, one of the first in Earth's history. Entire microbial worlds vanish, but the planet does not mourn, it does not notice, and in the aftermath something new becomes possible. Oxygen reshapes the sky. It reacts with sunlight, forming a thin layer of ozone high above the planet. For the first time, the surface is shielded from the sun's most destructive radiation. The world grows calmer, safer, still empty of animals, still silent, but no longer the same Earth that once glowed with molten fire and lifeless seas. The planet is waiting now, waiting for complexity, waiting for movement, waiting for awareness, and that waiting will continue for hundreds of millions of years more. This is where our first part comes to rest. Earth is alive but alone, prepared but unawakened. A world holding its breath long before anything could breathe back. The planet does not know it is waiting. There is no anticipation in the oceans, no expectation written into the wind. Earth continues as it always has, turning, cooling, breathing fire and stone into the sky, unaware that it has crossed a threshold from which there is no return. Oxygen lingers now. At first it is thin, barely noticeable. A trace presence mixed into the heavy atmosphere of carbon dioxide and methane, but even in small amounts it begins to change everything. The sky lightens just slightly, not blue not yet, but less opaque than before. Sunlight reaches the surface more consistently, warming the shallow seas and coastlines where microbial life is most dense. The microbes respond not with intention but with chemistry. Some perish, unable to survive in the presence of oxygen. Others adapt, their internal processes slowly reshaped by the new conditions. Over immense spans of time, new metabolic pathways emerge. Life learns in its blind and mechanical way how to tolerate the poison and eventually how to use it. But this learning is slow. So slow that tens of millions of years pass between each meaningful shift. Civilizations will one day rise and fall faster than a single microbial adaptation during this era. The oceans remain dominant. They cover most of the planet, dark and restless, endlessly stirred by tides pulled by a moon that still looms large in the sky. Coastlines are barren, no plants soften the land, no roots hold soil in place. Rain erodes bare rock directly into the sea. Every storm reshapes the land, every wave rewrites the shore. Nothing resists. Beneath the surface of the oceans, microbial mats spread across the seafloor like living carpets. Layer upon layer, they grow slowly upward, trapping sediment, building structures that rise only millimeters per century. These structures will later be called stromatolites. They do not move, they do not hunt, they do not compete in any conscious sense. Yet they are among the most successful forms of life Earth has ever known. For hundreds of millions of years, they dominate the planet. They absorb sunlight. They release oxygen. They persist. They change the world without ever knowing it. Passage of time remains imperceptible. Days are shorter than they will one day become. Years pass quickly. The moon gradually drifts farther away, stealing a little of Earth's spin with each passing tide. The planet slows. The rhythm of existence stretches. Still, there are no animals, no bodies large enough to cast shadows beneath the waves, no eyes to register light filtering down through the water, no mouths to open, no muscles to contract. Life exists everywhere, and yet nothing happens. There is no drama. No chase, no struggle that could be called a story, just survival through stability. And then very slowly life begins to experiment. Some cells begin to cluster together, not permanently, not yet. They remain independent, but they linger near one another longer than before. Chemical signals pass between them, faint and unreliable. These signals are not thoughts, they are not messages, they are simple reactions, one molecule triggering the release of another, but even this is new. For the first time, life is no longer entirely alone at the microscopic level. The environment continues to change. Oxygen levels rise unevenly. In some regions, the atmosphere becomes more oxidizing, while in others, ancient conditions persist. The planet becomes a patchwork of chemical landscapes, each favoring different forms of life. Volcanoes continue to erupt, injecting gases into the atmosphere and oceans. Continents shift slowly, carried atop the restless mantle beneath them. Land masses collide and separate, reshaping ocean currents and climate. Ice appears for the first time in Earth's history, not a permanent freeze but brief glaciations, episodes where temperatures dip low enough for ice to form at the poles, creeping outward before retreating again. The planet experiments with cold just as life experiments with complexity. Still, there are no animals, no awareness to register the changing climate, no fear of extinction, no memory of warmer times. Life continues indifferent to its own fragility. Within the oceans, a quiet revolution begins. Some cells develop internal structures, tiny compartments that perform specialized tasks. Energy production becomes more efficient. Waste is managed more carefully. Boundaries become more defined. These cells are larger than their ancestors, more complex, more fragile, but also more capable. They are the first eukaryotic cells. They contain nuclei. They organize their internal chemistry with unprecedented precision. They can afford complexity because oxygen now makes high-energy processes possible. But complexity comes at a cost. These cells reproduce more slowly. They require more stable conditions. They are less tolerant of environmental extremes. For a long time, they remain rare. The microbial world still dominates, vast and overwhelming in its numbers. Simpler life forms continue to blanket the planet, while these complex cells drift quietly among them, unnoticed and uncelebrated. Time passes, hundreds of millions of years. The sun grows brighter imperceptibly as it ages. Day by day, the planet receives slightly more energy than before. Climate patterns shift, oceans warm, ice retreats, chemical gradients deepen, new niches appear. Life responds not with intention, but with inevitability. Some eukaryotic cells begin to cooperate more closely. They remain attached after dividing, forming loose colonies. Each cell performs the same basic functions, but proximity allows for shared resources and protection. These colonies are not yet organisms. They have no division of labor, no hierarchy, no sense of self beyond the individual cell, but the idea of togetherness has entered the world. Over time, some cells within these clusters begin to specialize. One cell might focus more on energy production, another on reproduction, another on structural support. This specialization is unstable at first. Many attempts fail. Colonies collapse, cells revert to independence, but occasionally the arrangement holds. A new level of organization emerges. Still, there are no animals, no movement driven by desire, no sensation, no response to the environment beyond chemistry, and yet the foundation is being laid. Oxygen continues to accumulate in the atmosphere. The sky begins to clear further. The haze thins. Sunlight grows sharper, more direct. For the first time, the sky begins to hint at blue. Not the deep blue of modern Earth, but a pale suggestion, a lighter dome above the planet, filtering light in a new way. Ultraviolet radiation is partially blocked by the growing ozone layer. Surface environments become less hostile. Shallow waters grow safer. Life spreads into new regions. The land remains bare. Rock and dust dominate the continents. Rain continues to fall, carving channels that lead to empty seas. No soil forms because nothing lives on land long enough to create it. The silence persists. Then one of the most consequential changes in Earth's history occurs quietly without announcement. Cells begin to share genetic material more freely. Until now, life has relied primarily on vertical inheritance, traits passed from parent to offspring. But now genes move sideways, jumping between organisms through processes that have no purpose beyond chemistry. This horizontal exchange accelerates evolution dramatically. Useful traits spread quickly. Innovations propagate through populations in geological instants. Life becomes more adaptable, more flexible, more dangerous, still microscopic, still unaware, still without animals, but no longer slow. The pace of change increases. Ecological interactions grow more complex. Some cells begin to consume others, not by engulfing them violently, but by absorbing dissolved organic matter released when neighboring cells die. Predation in its faintest and most primitive form begins. Energy flows more efficiently through ecosystems. Waste becomes food, death becomes resource, the oceans grow richer. Layered microbial ecosystems form, stacked according to light availability and chemical gradients. Near the surface, photosynthetic organisms dominate. Below them, consumers feed on their byproducts. Deeper still, organisms rely on chemical energy from the planet itself. The seafloor becomes alive in a way it never has been before, yet still nothing sees, nothing hears, nothing feels. Earth remains a world without experience. The passage of another 100 million years brings further change. Cells develop internal skeletons, structures that help maintain shape and resist deformation. These cytoskeletons allow for more complex forms, enabling cells to stretch, bend, and interact mechanically with their surroundings. Movement becomes possible, not directed movement, not purposeful motion, but subtle shifts driven by internal dynamics. Cells can now position themselves more precisely. They can respond to gradients of light or chemicals by drifting in one direction rather than another. This is not choice, but it is the beginning of response. Some colonies of cells grow larger than ever before, visible to the naked eye if there were eyes to see them. They form soft, gelatinous sheets and filaments, drifting through the water or clinging to surfaces. They are fragile, they tear easily. They leave no fossils behind, but they represent something new, life that occupies space in a way that cannot be ignored. The planet feels fuller now, not crowded but no longer empty. The oceans teem with invisible activity. Chemical signals crisscross the water. Energy flows in complex loops. Feedback systems emerge, stabilizing some environments while destabilizing others. Earth begins to regulate itself not consciously but through the collective action of life. Atmospheric composition fluctuates, climate responds, ice advances and retreats. Life persists, still no animals, still no nervous systems. No pain, no pleasure, no fear, just chemistry learning how to persist. As the second billion years of Earth's history draws toward its close, the stage is nearly set. Oxygen levels approach a threshold where entirely new forms of metabolism become possible. Energy-rich reactions can now support larger bodies, more complex structures, and sustained activity. The building blocks of animal life exist, but they have not yet assembled themselves. The oceans remain calm in appearance, their surfaces reflecting the pale sun. Beneath, microbial worlds churn with invisible complexity. The land remains silent, waiting. Earth does not know what is coming. It has no concept of movement or hunger or eyes opening for the first time beneath ancient seas. It does not anticipate the sudden explosion of form and motion that will one day shatter this long, quiet equilibrium. For now it continues to turn, alive but unawake, and this is where we pause again. The planet has crossed from chemistry into complexity, but not yet into experience. In the next part, we will move closer to the moment when life learns to move, when the first bodies begin to take shape, and when the silence that has ruled Earth for billions of years finally begins to break. The silence does not end all at once. There is no single moment when the oceans suddenly fill with motion, no instant when the planet awakens in surprise at its own transformation. Change arrives the way it always has, quietly, unevenly, spread thin across vast spans of time. Earth continues to turn beneath the sun. Oxygen continues to gather in the air. Life continues to grow more complex, one small step at a time, deep beneath the ocean's surface, where sunlight fades into blue and then into black. Chemical energy rises from the planet itself. Along fractures in the crust, hydrothermal vents pour mineral-rich water into the sea, creating towering chimneys of stone. Around these vents, life thrives not because of light, but because of chemistry. Here, cells feed on sulfur, iron, and hydrogen, drawing energy directly from the planet's interior. These environments are ancient, stable, and rich. They become laboratories of evolution. Cells here grow larger. They develop thicker membranes to survive temperature extremes. They form symbiotic relationships, one cell living inside another, exchanging resources, sharing survival. Some of these partnerships become permanent. A smaller cell takes up residence within a larger one, providing energy in exchange for protection. Over countless generations, the two become inseparable. The smaller cell loses its independence. The larger cell gains power. This is how mitochondria are born, not through design, not through foresight, but through survival repeated so many times that separation is no longer possible. Energy production becomes dramatically more efficient. For the first time, cells possess enough energy to support true complexity, larger size, more internal structure, more sophisticated regulation. Life takes a quiet but decisive step forward. The oceans respond, populations expand, diversity increases. New forms appear, some fleeting, some persistent. Shapes vary, sizes fluctuate, interactions grow more intricate. Still, there are no animals, but the distance between what exists and what will exist is shrinking. Cells with mitochondria begin to dominate certain environments. They outcompete simpler forms in stable, oxygen-rich waters. Their descendants explore new niches, drifting into shallower seas where light penetrates more deeply. Here, sunlight is abundant, photosynthetic life flourishes. Layered ecosystems emerge, structured vertically through the water column. At the surface, light-driven organisms absorb energy. Below them, others consume their waste. Deeper still, life feeds on the remains of those above. Energy flows downward in slow, continuous cascades. Death becomes a regular part of the system, not as an event, but as a process. Cells die, break apart, dissolve, and are recycled almost immediately. Nothing is wasted, nothing is mourned. Time passes. The moon drifts farther away, lengthening Earth's days. The rhythm of light and dark slows. Night stretches a little longer. Day follows more gradually. The planet grows calmer. Storms still rage, but patterns stabilize. Climate zones become more defined. Equatorial waters remain warm. Polar regions cool. Ice becomes a recurring feature of Earth's poles. Glaciers advance and retreat over millions of years, grinding continents into dust, reshaping coastlines, altering sea levels. Each glacial episode resets the environment, erasing ecosystems and forcing life to adapt again and again. Extinction becomes routine, and life persists regardless. In the shallow seas, colonies of cells grow increasingly coordinated. chemical signaling becomes more reliable. Internal feedback loops stabilize collective behavior. Some colonies develop simple polarity, one end behaving differently from the other. This allows them to orient themselves relative to light or chemical gradients. Up and down begin to matter. Front and back begin to exist. These distinctions are subtle, but they mark a profound shift. For the first time, life is no longer symmetrical in all directions. It begins to organize itself in relation to the world around it. Movement follows. At first, it is slow and inefficient. Cells within a colony contract or expand in coordinated ways, causing the entire structure to drift or twist. Not purposeful movement, but not entirely passive either. The boundary between life and environment begins to blur. Some of these colonial forms grow large, several centimeters across, floating gently through the water or resting on the seafloor like soft mats. They absorb nutrients across their entire surface. They have no mouths, no digestive systems, no organs. They exist as living surfaces, and still there are no animals, no predators, no prey, no nervous systems to register danger or opportunity. The world remains peaceful but not static. Oxygen levels continue to rise. The sky grows clearer. The sun shines brighter through thinning haze. Shallow waters become bathed in light. With more energy available, life experiments more freely. Some organisms develop protective outer layers, simple skins that help regulate internal conditions. Others evolve internal scaffolding, giving them more defined shapes. Cells adhere more strongly to one another. They coordinate division. They differentiate more reliably. True multicellularity begins to stabilize. This is not yet the age of animals, but it is the doorway. Life forms now exist that cannot survive as single cells. Their parts depend on one another completely. If separated, they die. A new level of individuality emerges. These organisms have no brains, no nerves, no senses, but they are no longer collections of independent cells. They are unified wholes. They grow. They maintain internal balance. They respond as a group to changes in their environment. The concept of an organism is born. Earth, still unaware, continues its slow transformation. Continents shift. Ocean basins deepen and shallow. Mountain ranges rise only to be eroded away. Volcanic islands emerge and sink back beneath the waves. Carbon cycles through atmosphere, ocean, and rock. Climate oscillates between warm and cool states. Life adapts again and again. Some multicellular organisms develop internal cavities, allowing water to flow through their bodies. This increases surface area for nutrient exchange. It allows larger sizes. Water enters water leaves. Flow becomes important. Direction matters. Inside and outside become more clearly defined. These organisms resemble little more than tubes or sacs anchored to the seafloor or drifting slowly through the water. They feed passively, filtering nutrients from the sea. They are still fragile, still easily destroyed by environmental change, but they are something new. They occupy space. They alter water flow. They create microhabitats for other organisms. The oceans grow more structured. Interactions multiply. Some organisms begin to feed directly on others, not merely absorbing waste but consuming living tissue. This is not yet predation as we know it, but it is a step closer. Energy transfers become more direct. Competition intensifies. Life begins to push back against life. The planet feels subtly different now. Not louder, sound still has little meaning beneath the waves, but busier. More dynamic, more crowded, yet still there are no animals, no eyes to track motion, no jaws to seize prey, no nervous systems to coordinate rapid response. Movement exists, but it is slow. Change exists, but it is patient. Another 100 million years pass, then another. The sun continues its steady brightening. Oxygen reaches levels high enough to support sustained aerobic metabolism across much of the ocean. Energy becomes abundant. With abundance comes experimentation. Some organisms develop specialized cells for contraction. These cells shorten when triggered by chemical signals, causing parts of the body to move. At first, this movement is minimal, a gentle ripple, a slight bend, but even this is revolutionary. For the first time, life can move itself deliberately, not consciously, not strategically, but actively. The ocean floor begins to host organisms that can adjust their position, however slowly. They can tilt toward light. They can retract when disturbed. They can expand and contract rhythmically. Response becomes more immediate. The delay between stimulus and reaction shortens. Chemical signaling networks grow more complex. Electrical properties of cell membranes begin to play a role in communication, allowing signals to propagate faster than diffusion alone. This is the faintest whisper of nervous systems to come. The oceans grow restless. Not in appearance, waves still rise and fall as they always have, but in the hidden dynamics beneath the surface. Life presses against the boundaries of what is possible. The world is approaching a tipping point. The long age of microbial dominance is ending. The planet has spent billions of years preparing, cooling, oxygenating, stabilizing, experimenting. Now the ingredients are in place. All that remains is assembly. Earth does not know this. It continues to turn beneath the sun, indifferent and patient. But soon, very soon, in geological terms, the silence that has ruled the planet since its birth will begin to fracture. Bodies will take shape, movement will accelerate, senses will emerge. The age of animals is near. The transition does not announce itself. There is no clear dividing line etched into the stone of time, no sudden shift from stillness to motion that could be marked and named. Instead, the world slides gently, almost imperceptibly, into something new. For billions of years, life has existed as chemistry arranged into persistence. Now that chemistry begins to organize itself around response. The oceans remain calm at the surface, reflecting the pale light of the sun. Beneath, life continues to thicken, diversify, and experiment. The seafloor is no longer an empty plain of sediment and stone. It is layered with living structures, soft, slow, and quietly complex. Some organisms have learned to anchor themselves more firmly. They secrete substances that bind them to rock, allowing them to remain in favorable positions rather than drifting helplessly with the currents. Others choose the opposite strategy, detaching entirely and floating freely, surrendering control in exchange for reach. Two ways of being emerge, staying and moving. Neither is conscious, neither is chosen. They arise because they work. As bodies grow larger, internal coordination becomes more important. Chemical signals alone are no longer sufficient to manage the increasing distances between cells. Delays become costly, responses become sluggish, life answers with innovation. Some cells specialize not in feeding or reproduction but in communication. Their membranes become electrically excitable. When triggered, they pass signals rapidly along chains of neighboring cells. These signals are not thoughts, they are not feelings, they are simply faster messages, but speed changes everything. For the first time, a stimulus in one part of an organism can produce a near immediate response in another. Contraction follows contact, retraction follows disturbance. The environment begins to matter more directly. Light, pressure, chemical gradients all begin to influence behavior not over generations but within moments. The first primitive sensory systems emerge. They do not see, they do not hear, they do not interpret, but they register change. The boundary between organism and environment sharpens. Life is no longer just shaped by the world. It begins in a limited way to react to it. the oceans become more interactive. Some organisms learn to detect shadows, subtle changes in light intensity as objects pass above them. Others respond to vibrations in the water, contracting when disturbed. These responses are slow by later standards, but they are revolutionary nonetheless. For the first time, life does not merely endure change. It responds to it. Movement becomes more purposeful, not driven by desire or intention, but by automatic reactions encoded in chemistry and electricity. Organisms contract toward nutrients. They withdraw from harmful conditions. They orient themselves to maximize energy intake. The water fills with gentle motion, ripples of living matter adjusting, pulsing, shifting. Still, there are no animals as we would recognize them. No heads, no tails, no limbs, but the pieces are assembling. Over time, symmetry emerges. Some organisms develop radial symmetry, arranged around a central axis. Others develop bilateral symmetry with a distinct front and back, left and right. This is not aesthetic, it is practical. A front allows interaction with the environment before the rest of the body follows. A back trails behind, carrying systems that no longer need to face the world directly. Forward and backward become meaningful. Direction enters life. With direction comes anticipation, not conscious anticipation, but structural preparation. Sensory cells cluster toward the front. Contractile tissues align to support movement in a preferred orientation. Bodies become streamlined. Water flows differently around them. Efficiency increases. The oceans begin to host forms that move consistently in one direction rather than drifting aimlessly. Their motion is slow, deliberate, driven by waves of contraction traveling through their bodies. They leave faint disturbances behind them, temporary currents that fade quickly in the vastness of the sea. The seafloor changes too. Some organisms burrow into soft sediment, seeking shelter or nutrients below the surface. Their movement stirs the ocean floor, mixing layers of sediment that have lain undisturbed for millions of years. This churning releases trapped chemicals, alters oxygen levels, reshapes habitats. Life begins to engineer its own environment. The feedback loops grow stronger. As organisms modify their surroundings, new niches appear. Other forms evolve to exploit them. Diversity increases not smoothly but in bursts separated by long plateaus. Extinction remains common. Most experiments fail. The fossil record, where it exists, is filled with ghosts of forms that appeared briefly and vanished without descendants, but a few persist. A few lineages find stability and flexibility. The oceans grow crowded. Not crowded in the human sense, but dense with interactions. Organisms brush past one another. Chemical signals overlap. Competition for space and resources intensifies. For the first time, scarcity becomes meaningful. When resources are limited, efficiency matters, speed matters, sensitivity matters, life responds. Some organisms develop protective outer layers, early skins that shield delicate internal tissues from the environment and from other organisms. These layers also help maintain internal chemistry, buffering against external fluctuations. Inside, tissues differentiate further. Cells take on specialized roles more reliably. Coordination improves. Simple digestive cavities form, allowing organisms to take in larger food particles rather than relying solely on dissolved nutrients. Consumption becomes more direct. Energy transfer accelerates. The ecological web tightens. Still, no one hunts. Still, no one flees. But the groundwork for both is being laid. As bodies grow larger, the cost of immobility rises. Remaining stationary makes one vulnerable to burial, starvation, or environmental change. Movement, even slow movement, offers advantage. Selection favors organisms that can reposition themselves effectively. Muscle-like tissues become more powerful, electrical signaling becomes more refined, sensory cells become more numerous, response times shorten. The world feels faster, not to the planet, but within life itself. The oceans, once ruled by stillness, now hum with quiet activity. Above, the atmosphere continues to change. Oxygen levels stabilize at higher concentrations. The ozone layer thickens, shielding the surface from harmful radiation. The climate grows more moderate overall, though punctuated by extremes. Shallow seas expand and contract as sea levels rise and fall. Continental shelves become vast, sunlit habitats rich in nutrients. These shallow waters become crucibles of innovation. Light penetrates deeply. Energy is abundant. Environmental gradients are strong and varied. Life flourishes here. It diversifies rapidly. Forms appear that are larger, flatter, more mobile. Some glide across surfaces. Others pulse gently through the water. Some attach temporarily, then release, drifting to new locations. Interactions increase. Accidental contact becomes common. With contact comes pressure. Some organisms begin to benefit from harming others, not intentionally, but as a consequence of feeding strategies. Structures that scrape, pierce, or engulf become advantageous. Predation in its earliest form emerges. At first, it is clumsy and rare. Organisms consume others opportunistically when proximity allows. There is no chase, no pursuit, but even this changes everything. For the first time, life can be killed directly by life. Selection pressures intensify dramatically. Being edible becomes a liability. Defense becomes valuable. Organisms respond by thickening outer layers, secreting protective coatings, or developing shapes that make ingestion difficult. Some retreat into burrows. Others grow spines or harden their surfaces with minerals drawn from seawater. The first skeletal elements appear, not yet bones, but stiffened structures that provide support and protection. The arms race begins, evolution accelerates, the pace of change quickens as interactions grow more complex. Adaptations stack upon adaptations, small advantages compound, the oceans transform. What was once a microbial soup becomes a dynamic ecosystem structured by interaction, competition, and response. Movement becomes more coordinated. Sensory input becomes more integrated. Electrical signaling networks grow more elaborate. Some organisms now possess simple nerve nets, distributed systems of excitable cells that coordinate behavior across the body. They have no brains, no centralized control, but they can integrate information from multiple sources and produce coherent responses. Touch triggers contraction. Light triggers orientation. Chemical cues trigger feeding behavior. The organism behaves as a whole. This is a profound shift. For the first time, life is not merely a collection of parts working independently. It is an integrated system. The foundations of behavior are laid. Earth has crossed another threshold. The long age of purely chemical life is over. The age of responsive life has begun. Still, animals as we know them have not yet arrived. There are no eyes scanning the water, no jaws snapping shut, no swift swimmers cutting through the sea, but the silence is thinning. The ocean is no longer a place of passive existence. It is a place of interaction, consequence, and change. Life now shapes its own destiny more directly than ever before. And Earth continues to turn, indifferent and patient, beneath a sky that grows ever bluer. The stage is set for a transformation that will come suddenly, explosively, in geological terms, a burst of form and function that will fill the oceans with unfamiliar shapes and movements. A moment when bodies will diversify at a pace never seen before. A moment when the first true animals will emerge. That moment is close now. The change, when it finally arrives, does not feel sudden to the planet. Earth has known nothing but change for more than 4 billion years. Continents have risen and vanished. Oceans have formed, frozen, and reshaped themselves. Atmospheres have thickened and thinned. Ice has crept across the surface and retreated again into memory. But within the living world, something new is happening now. The slow experiments of life, those cautious, incremental adjustments stretched across unfathomable time, begin to accelerate. The oceans are no longer dominated by simple, passive forms. Movement has become common. Interaction has become unavoidable. The presence of one organism increasingly shapes the fate of another. Life has entered an age of consequences. In the shallow seas where sunlight pours down and nutrients swirl in abundance, ecosystems grow dense. Organisms crowd together, layered atop one another, competing for space and energy. Here, survival depends not only on chemistry but on response. The nerve nets that once merely coordinated simple contractions now grow more refined. Electrical signals travel faster. Patterns of activation become more predictable. Some pathways strengthen through repeated use, while others fade away. Behavior begins to stabilize, not learned behavior, not memory in any conscious sense, but reliable patterns of response encoded in structure. If touched, retract; if shaded, orient; if nutrient concentration increases, extend and absorb. Life begins to behave consistently. Bodies grow more distinct. Some organisms develop clear anterior regions, front ends where sensory cells cluster more densely. This front encounters the environment first. It probes, it reacts. Behind it, tissues follow. This arrangement confers advantage. Directional movement becomes smoother. Response becomes faster. The idea of a head, primitive, incomplete, begins to form, not a brain, but a gathering place. As bodies elongate, internal organization increases. Digestive cavities extend lengthwise, allowing food to move through the body rather than simply in and out of a single opening. Waste is expelled away from intake. Efficiency improves. Energy flows more smoothly. Organisms can grow larger without suffocating themselves in their own byproducts. The seafloor changes. Burrowing organisms disturb sediment layers that have lain untouched for eons. Oxygen penetrates deeper into the ground. Chemical gradients shift. New habitats emerge below the surface. Life spreads into them. The churning of sediments alters ocean chemistry on a global scale. Nutrients cycle more rapidly. Productivity increases. Life feeds on life. The pace of evolution quickens further. Predation becomes more common. Some organisms now actively consume others, not accidentally, not opportunistically, but as a primary mode of survival. They engulf smaller forms, digesting them internally. This is not yet hunting. There is no pursuit, but there is intent encoded in structure. Mouth-like openings form. Digestive enzymes become more potent. Feeding becomes more selective. Being small and slow grows dangerous. Defenses evolve in response. Hard outer coverings become more widespread. Minerals dissolved in seawater, calcium, silica, are incorporated into tissues, stiffening them, making them harder to penetrate. The first shells appear. Not elaborate, not decorative, but effective. Life arms itself. With protection comes confidence. Organisms venture into open spaces rather than clinging to shelter. They grow larger, more exposed. Mobility increases. Some organisms develop appendage-like structures, flexible extensions that aid in movement or feeding. These appendages are not limbs as we know them, but they represent another step towards specialization. Different parts of the body begin to do different things. Division of labor deepens. Muscle-like tissues grow stronger. Repeated contractions allow for more forceful movement. Some organisms can now propel themselves short distances through the water, rather than merely drifting or creeping. Swimming is born slow at first, ungraceful but unmistakable. The water is no longer merely a medium, it is a space to move through. With movement comes a new sensory challenge, orientation. Organisms must know which way is up, which way leads to food, which way leads to danger. Specialized cells sensitive to gravity and chemical gradients help provide this information. Integration increases. Responses become coordinated across the body. The nerve nets that once sufficed for simple forms now grow more centralized. Dense clusters of signaling cells form near the front of the body, acting as hubs. These hubs are not brains, but they are beginnings. They allow faster processing of sensory input. They coordinate more complex movements. They integrate multiple signals into unified responses. Life grows more responsive, more adaptable, more alive. The oceans reflect this transformation. Where once movement was rare and slow, now currents swirl around swimming forms. Shadows pass beneath the surface. Disturbances ripple outward from encounters between organisms. The water feels crowded, not crowded in the human sense, but full of presence. Still, the land remains barren. Continents rise above sea level, their surfaces sculpted by wind and rain. Rivers carve channels through naked rock. Dust blows across empty plains. Nothing lives there yet. The drama unfolds entirely beneath the waves. Time continues its patient march. Millions of years pass. The sun grows brighter, climate shifts, sea levels fluctuate, shallow seas expand and contract, repeatedly creating and destroying habitats. Each change pressures life to adapt, those that cannot vanish, those that can diversify. A feedback loop intensifies, interaction drives innovation, innovation drives interaction. Evolution enters a new mode. The genetic toolkit of life expands. Regulatory genes, those that control when and where other genes are activated, become more sophisticated. Small genetic changes now produce large structural effects. Bodies diversify rapidly. New forms appear faster than before. Flat bodies, elongated bodies, segmented bodies. Segments allow repetition, structures repeated along the length of the body, providing flexibility and redundancy. Damage to one segment is not fatal. Movement becomes more controlled. Segmentation is a powerful idea. It will echo through future life in many forms. The oceans fill with experiments. Some organisms crawl along surfaces, others swim freely. Some attach temporarily, then detach, exploring new areas. Predation becomes more dynamic. Speed begins to matter. Being able to react quickly can mean the difference between being eaten and escaping. Selection favors faster signaling, stronger muscles, more efficient coordination. Nervous systems grow more elaborate. For the first time, conduction of signals becomes directional. Information flows from sensory regions toward coordination centers, then outward to effectors. The architecture of control takes shape. Life approaches a tipping point, and then over a span of time that, while vast, is brief compared to what came before, diversity explodes. New body plans appear in rapid succession, forms with articulated appendages, forms with hardened exoskeletons, forms with internal support structures. Eyes begin to emerge, not complex cameras, not image-forming organs, but patches of light-sensitive cells capable of distinguishing light from dark. Vision in its simplest form enters the world. Everything changes. Light becomes information. Movement becomes visible. Predation intensifies dramatically. Those that can see can hunt. Those that can be seen must hide, armor themselves, or flee. An evolutionary cascade unfolds. The oceans transform into arenas of motion and interaction. The age that will one day be called the Cambrian is beginning. Animals, true animals, now exist. They have bodies designed for movement, nervous systems designed for response, sensory organs designed to sample the world. They experience in the most primitive sense what happens to them. The silence that ruled Earth for billions of years finally breaks, not in sound but in activity. Life has awakened, yet this awakening is only the beginning. The first animals are strange by modern standards, soft-bodied, unfamiliar, experimental. Many leave no lasting descendants. Entire lineages rise and fall in the blink of geological time, but the principle has been established. Life can move, life can sense, life can interact rapidly with its environment. The world will never be the same. Earth, still unaware, continues its steady rotation beneath a sky now unmistakably blue. The oceans, once silent and empty, teem with motion. And from this point forward, the story of life will accelerate, branching, competing, experimenting, until it produces forests, reefs, predators, prey, and eventually, minds capable of wondering how it all began. For now, we pause here at the threshold where animals first emerge, where the ancient stillness finally gives way to motion. The oceans do not celebrate the arrival of animals. There is no recognition, no ceremony marking the moment when life crosses from simple response into something richer and more complex. The water continues to move as it always has. The tides rise and fall. The sun traces its slow arc across the sky, but beneath the surface the world has changed forever. The early animal oceans are unfamiliar, even alien. Shapes drift and dart through the water, some soft and translucent, others armored and rigid. Bodies take forms that will one day vanish completely, leaving no living descendants behind. This is a time of experimentation when evolution explores possibilities without restraint. Nothing is fixed yet. Some animals glide gently, propelled by slow waves of contraction passing through their bodies. Others crawl along the seafloor, using repeated segments to push themselves forward. Some remain anchored for most of their lives, filtering the water for nutrients, while others roam continuously, searching for food. Predators and prey now share the same space. This changes behavior in fundamental ways. Movement becomes cautious or sudden. Stillness becomes a strategy. Burrowing offers refuge. Camouflage, simple patterns of light and dark begins to appear, breaking up outlines and confusing would-be attackers. The ocean is no longer a passive environment. It is a place of risk. Eyes, still crude, grow more common. Some detect only brightness and shadow. Others begin to distinguish direction, allowing animals to orient themselves relative to light sources or moving objects. Those that see gain advantage. They detect food sooner. They detect danger earlier. Their responses become faster and more precise. Selection favors them. The arms race intensifies. Hard shells thicken. Spines lengthen. Bodies flatten or narrow to slip through tight spaces. Speed increases. Muscle fibers grow stronger and more efficient. Nervous systems become more centralized. Clusters of neurons grow denser at the front of the body, forming primitive brains not capable of thought but capable of integration. Sensory input converges here. Motor commands diverge outward. The animal becomes a coordinated whole. For the first time in Earth's history, something moves because it wants to, not consciously, not reflectively, but because its internal state compels action. Hunger drives motion, threat drives retreat. This is not awareness as humans know it, but it is no longer mere chemistry reacting blindly. The animal world now contains experience, however faint. The seafloor transforms. Burrowing animals mix sediments continuously, oxygenating layers that were once stagnant. Microbial communities shift in response. chemical cycles accelerate, the ocean floor becomes dynamic. Reefs begin to form, not the coral reefs of much later eras, but early biological structures built by organisms that secrete rigid frameworks. These structures provide shelter, alter currents, and create complex three-dimensional habitats. Diversity explodes within these environments. Life now builds with life. Predation drives specialization. Some animals develop grasping appendages, allowing them to seize prey. Others evolve defensive reflexes, rapid contractions that pull vulnerable parts away from danger. Response times shrink. Milliseconds begin to matter. The world feels faster. Generation by generation, evolutionary change accelerates. Genetic variation spreads rapidly through populations shaped by intense selection pressures. The fossil record, where conditions allow preservation, captures this moment as a sudden flowering, a burst of forms appearing seemingly all at once. But this explosion is only sudden in hindsight. It is the culmination of billions of years of preparation. The atmosphere, now rich in oxygen, supports high-energy metabolism. The oceans, structured and nutrient-rich, sustain large populations. The genetic toolkit of life is flexible and powerful. Everything is ready. The early animal ecosystems stabilize. Food webs become layered. Primary producers capture energy. Herbivores consume them. Carnivores prey upon herbivores and sometimes upon each other. Energy flows through bodies now, not just through chemistry. Death becomes frequent and visible, but life responds with resilience. Extinction no longer wipes the slate clean. It reshapes the community, opening niches for others to fill. Evolution becomes creative. Over time, some animal lineages begin to dominate. Their designs prove robust, adaptable, capable of surviving environmental shifts. Others vanish, leaving behind only traces in stone. The oceans grow crowded in a new way. Movement is everywhere. Water churns with life. Above, the continents remain empty. The land is harsh, bathed in sunlight, stripped of nutrients, exposed to wind and temperature extremes. No animals venture there yet. Life remains bound to water, but even here change is underway. Some animals begin to tolerate brief exposure to air when tides retreat, when waves crash high onto rocks. Protective coverings prevent desiccation. Gas exchange adapts. The boundary between sea and land begins to blur. Still, the great majority of life remains submerged, thriving in the ancient seas. The planet continues to turn. Days lengthen further as the moon drifts away. The rhythm of life adjusts. Biological clocks, primitive but real, synchronize with cycles of light and dark. Reproduction becomes timed. Behavior becomes rhythmic. Life aligns itself with the planet's motion. Climate remains variable. Ice advances and retreats at the poles. Sea levels rise and fall. Shallow seas come and go. Each shift challenges life. Some ecosystems collapse, others expand. Animals disperse, migrate, diversify. The evolutionary tree branches wildly. Some lineages experiment with internal skeletons rather than external armor, allowing for greater flexibility and growth. Others refine their exoskeletons, perfecting jointed limbs and protective shells. Segmentation becomes common. Modularity proves powerful. Limbs articulate. Movement becomes more precise. Speed increases again. The oceans are alive with activity. Predation becomes sophisticated. Chase and escape now occur not at lightning speed but with purpose and direction. Animals anticipate movement. They adjust course. They respond dynamically. The nervous system is no longer merely reactive. It becomes predictive. Simple learning appears, not memory as humans know it, but modification of behavior based on past stimulation. Life begins to adapt within a lifetime, not just across generations. The world grows richer, yet even in this flourishing, the planet remains indifferent. Earth does not notice the rise of animals any more than it noticed the formation of oceans or the accumulation of oxygen. It continues to change according to forces far larger than life itself. Volcanoes erupt. Continents drift, asteroids occasionally strike. Life absorbs the impacts and continues. The age of animals expands. New eras will follow, eras of reefs and forests, of fish and land creatures, of wings and intelligence, but all of that lies far ahead. Here in these early animal oceans, the foundations are laid. Life has crossed the threshold from chemical persistence into active engagement with the world. The silence that once ruled the planet has been replaced by motion, interaction, and experience. And yet, compared to what is still to come, this world remains simple. No creature yet knows fear as we know it, no mind yet reflects, no memory yet spans years. Those developments will require more time, vast amounts of it. For now, Earth rests in a new equilibrium, alive, active, and endlessly creative. The planet settles into this new rhythm without resistance. Earth has always been a place of motion, tectonic plates sliding, magma rising, oceans circulating heat from equator to pole. Now layered atop these ancient processes, another kind of motion spreads everywhere, biological motion. Life moves not only because it must, but because it can. The early animal oceans mature. What began as an explosion of unfamiliar forms slowly organizes itself into something more stable. Ecosystems take shape and persist for long stretches of time. Food webs become more predictable. Certain body plans prove resilient, returning again and again in slightly altered forms. Others fade away. The strange experiments of the earliest animals, soft-bodied creatures with no clear descendants, gradually give way to lineages that will shape the future. Arthropod-like forms refine their jointed limbs. Worm-like bodies specialize for burrowing and sediment mixing. Jellyfish-like organisms master the art of drifting and pulsing through open water. Each solution solves a problem. Each carries trade-offs. Life becomes less chaotic, but no less dynamic. Predation continues to drive innovation. As hunters improve, prey respond. As prey grow harder to catch, hunters adapt again. Speed increases incrementally. Reflexes sharpen. Sensory organs diversify. Eyes, once simple patches of light sensitivity, begin to curve inward, forming primitive chambers that can detect direction and movement more precisely. These early eyes do not form images as we understand them, but they offer something invaluable: warning. A shadow moving too quickly means danger. Animals that can sense this survive longer. Nervous systems grow denser and more centralized. Neuron clusters expand, allowing more sophisticated integration of sensory information. Coordination improves, movement becomes smoother, more controlled. The animal body becomes an instrument, responsive, adaptive, capable. Behavior grows more complex. Some animals develop daily rhythms, becoming active at certain times and inactive at others. Others synchronize reproduction to environmental cues, temperature changes, light cycles, chemical signals in the water. Life becomes timed. The planet's cycles, day and night, tides, seasons, are now mirrored within living systems. Earth and life grow intertwined. The seafloor reflects this intimacy. Bioturbation, the constant mixing of sediment by burrowing animals, reshapes entire regions of the ocean floor. Oxygen penetrates deeper. Microbial communities reorganize. Nutrient availability changes. The chemistry of the oceans shifts as a result of animal activity. Life alters the planet not just by existing, but by behaving. Reefs grow larger and more complex. Early reef builders construct rigid frameworks that deflect currents, trap sediments, and create calm pockets of water. Within these sheltered spaces, new communities flourish. Small animals find refuge from predators. Filter feeders exploit steady flows of nutrient-rich water. Algae and microbes coat surfaces, forming the base of local food webs. Reefs become centers of diversity. The ocean begins to resemble a mosaic, different habitats stitched together by currents and movement. Open water, shallow shelves, deep slopes, reef systems, muddy plains, each hosts its own cast of creatures. As ecosystems diversify, so too does behavior. Some animals become specialists, adapted to narrow niches. Others remain generalists, capable of surviving in a range of conditions. Specialists thrive when conditions are stable. Generalists endure when conditions change. Both strategies persist. Time continues its slow advance. Millions of years pass. The climate fluctuates. Periods of warmth give way to cooler intervals. Ice forms at the poles and retreats again. Sea levels rise and fall, repeatedly flooding and draining continental shelves. Each cycle reshapes habitats. Animals respond by migrating, adapting, or going extinct. The evolutionary tree continues to branch. Some lineages experiment with internalizing support structures, cartilage-like tissues that provide shape without the weight of mineralized shells. These structures allow for greater flexibility and faster movement. Others refine their external skeletons, developing articulated joints that permit precise control of limbs. Locomotion diversifies: crawling, swimming, jet propulsion, undulation. The water fills with motion of many kinds. Predation becomes more sophisticated. Some animals stalk. Others ambush, some chase briefly before abandoning pursuit. Others rely on stealth and patience. Defensive behaviors evolve in parallel. Some animals freeze when threatened, relying on camouflage. Others flee rapidly. Some curl inward, protecting vulnerable parts. Others brandish spines or toxic secretions. The ocean becomes a place of constant negotiation between risk and reward. Life grows more alert. The earliest forms of learning appear not as conscious thought, but as changes in neural responsiveness. Repeated exposure to a stimulus modifies reaction. An animal that survives an encounter may respond differently the next time. Behavior gains a past. This is subtle, but it is transformative. The seeds of memory are planted. Still, this world remains entirely aquatic. No animal has yet claimed the land. The continents, though shaped by rivers and weather, remain empty of macroscopic life. They bake under the sun during the day and cool rapidly at night. Nutrients wash quickly into the sea. There is little reason for animals to venture here, yet the boundary is not absolute. Along coastlines, tides expose organisms briefly to air. Waves strand animals on rocks. Pools of seawater evaporate under sunlight, concentrating salts and changing chemistry. These edge environments are harsh, but they are also opportunities. Some animals tolerate these fluctuations better than others. Protective outer layers reduce water loss. Gas exchange surfaces adapt to function in both water and air for short periods. Selection quietly favors these traits. The shoreline becomes a testing ground. Life experiments with the idea of land, but for now the sea remains the cradle. As animal life flourishes, the microbial world does not disappear. Bacteria and archaea continue to dominate in sheer numbers. They recycle nutrients, fix nitrogen, and drive chemical transformations essential to ecosystems. Life remains layered. Animals depend on microbes whether they know it or not. Symbiosis becomes common. Some animals host microbes within their bodies, relying on them to digest food or synthesize essential compounds. These partnerships increase efficiency and expand dietary options. Life becomes cooperative as well as competitive. The complexity of ecosystems deepens. Food webs become intricate networks rather than simple chains. Energy flows through many pathways. Stability increases, but so does vulnerability. A disruption in one part of the system can ripple outward. Earth's history is punctuated by such disruptions. Volcanic eruptions inject gases into the atmosphere. Asteroid impacts disturb climate. Tectonic shifts alter ocean circulation. Life endures but not unchanged. Extinction events remove dominant groups and open space for others to rise. These cycles are not failures, they are engines of change. The early animal oceans experience their own pulses of loss and recovery. Some lineages vanish entirely, others radiate into newly available niches. The pattern repeats, life proves resilient. As time passes, animal body plans become more refined, redundancy increases, systems back up one another, organisms become harder to kill accidentally. Developmental processes grow more regulated, embryonic stages follow more reliable sequences. Variation becomes constrained around successful designs. Evolution slows slightly not in rate but in scope. The wild experimentation of the earliest animal age gives way to refinement. The world feels settled but alive. Earth continues to turn. The moon continues to drift away, lengthening days further. Tides weaken gradually. Coastal environments change in response. Animals adapt again. The sun grows brighter. Long-term climate trends shift. The stage is being prepared for the next great transformation. Plants, though still confined to aquatic environments for now, begin to play larger roles in shaping ecosystems. Photosynthetic life continues to alter atmospheric composition subtly but persistently. Oxygen remains abundant, energy remains plentiful, conditions remain favorable for complexity. The path forward is long. From these early animal seas will come fish, forests, insects, reptiles, mammals, and minds capable of reflection. But none of that is inevitable. It will require time, vast time measured not in lifetimes, but in the slow rearrangement of continents and climates. For now, Earth rests in a dynamic balance, alive, active, and endlessly unfolding. The age of animals has begun, but it is still young. Time does not rush forward, it never has. Even now, as animal life spreads and diversifies across the oceans, the pace of the planet itself remains slow and unhurried. Continents drift at the speed of growing fingernails. Mountains rise only to be worn down grain by grain. The moon continues its quiet retreat, lengthening the days by fractions of a second over millions of years. Life adapts to all of it. The early animal oceans deepen into maturity. Ecosystems that once felt experimental now carry a sense of permanence. Certain regions remain dominated by familiar forms for tens of millions of years. Others change more rapidly, responding to shifting currents, temperatures, and chemistry. The ocean becomes layered not only in depth but in time. Some lineages persist almost unchanged for astonishing spans, their designs good enough to weather countless environmental swings. Others evolve rapidly, branching into new forms that rise and fall like brief thoughts in the mind of the planet. Evolution does not aim. It responds. In shallow coastal waters, complexity increases fastest. These environments are rich in light and nutrients, but also unstable. Sea levels fluctuate, storms reshape shorelines, salinity shifts with rainfall and evaporation. Life here must be flexible. Animals that inhabit these zones develop resilience. Their bodies tolerate variation, their behaviors adjust quickly. Their reproductive strategies ensure that at least some offspring survive unpredictable conditions. Eggs are released in vast numbers. Larvae drift with currents, spreading risk across space. Most do not survive, enough do. In deeper waters, stability favors specialization. Conditions change slowly. Food arrives in steady, if sparse, flows. Here, animals evolve strategies focused on efficiency and longevity. Slow movement, low energy consumption, delayed reproduction. Different worlds separated by depth and distance, but bound together by the same ocean. Predation remains the dominant force shaping behavior. As predators refine their tools, prey refine their defenses. This coevolution drives a steady escalation, not toward perfection, but toward balance. No adaptation remains unchallenged for long. Speed invites counter-speed. Armor invites stronger jaws. Camouflage invites sharper vision. The result is diversity. No single form dominates forever. The nervous systems of animals continue to evolve. What began as diffuse nerve nets now, in some lineages, organizes into longitudinal cords, bundles of nerve fibers running the length of the body. These cords improve coordination between distant segments, allowing smoother, more powerful movement. Control becomes hierarchical. Local reflexes manage immediate responses, while centralized regions integrate broader sensory input. The animal body begins to operate as a layered system. This architecture will persist in various forms for hundreds of millions of years. Behavior grows more nuanced. Some animals exhibit patterns that resemble caution. They hesitate at the edges of open spaces. They retreat when stimuli are ambiguous. They test their environment with tentative movements. Others become bold, venturing into exposed areas in search of food. These tendencies are not choices. They are expressions of nervous systems shaped by selection. Still, the effect is unmistakable. Animals behave differently. The oceans now contain something akin to personality, not individuality in the human sense, but variation in response that influences survival. Life grows richer. The physical structure of ecosystems continues to change. Reefs expand and erode. Sediment plains shift. Currents alter their paths as continents slowly rearrange the ocean basins. New seas open, others close. Isolation becomes a powerful force. Populations separated by changing geography evolve independently. Over time, they diverge, accumulating differences until they can no longer interbreed. Speciation accelerates. The tree of life branches relentlessly. Some branches grow thick and enduring, others remain thin and fragile. Extinction prunes constantly. The rhythm of rise and fall becomes a defining feature of life. The atmosphere remains stable enough to support complexity, but not static. Oxygen levels fluctuate within bounds. Carbon dioxide cycles through ocean and rock. Climate remains variable. Ice ages return intermittently, locking water in polar caps and lowering sea levels. Shallow seas shrink, habitats compress, life retreats. When ice melts, seas expand again, new habitats appear, life surges forward. These pulses create opportunities for innovation. Lineages that survive bottlenecks often emerge transformed, carrying traits that will shape future ecosystems. The planet learns through loss. As animal life flourishes, the chemistry of the oceans continues to shift. The accumulation of calcium carbonate skeletons alters seawater composition. Sediments change, carbon becomes locked into rock more efficiently. Life influences climate indirectly. The planet responds in kind. Feedback loops grow stronger. Earth and life become inseparable processes. Yet still, the land remains empty. The continents are vast, silent expanses of rock and dust. Rivers carve channels that lead nowhere. Winds sweep across plains untouched by roots or leaves. From the perspective of the ocean, the land is an alien world, but along the margins, life presses closer. Some animals venture into tide pools, surviving hours of exposure as water recedes. Their tissues tolerate brief drying, their metabolism slow. Others crawl across wet surfaces, feeding on microbial films coating rocks. These behaviors are not new species yet, they are experiments. The shoreline becomes a boundary zone where selection is intense. Those that fail perish quickly. Those that succeed gain access to new resources. Still, animals cannot yet complete their life cycles on land. Water remains essential for reproduction, respiration, and support, but the direction of change is clear. Life is probing the limits. In the oceans, complexity continues to build. Some lineages develop more efficient respiratory surfaces, extracting oxygen from water more effectively. Others evolve circulatory systems to distribute oxygen internally, supporting larger body sizes. Size increases confer advantages, greater reach, stronger movement, reduced vulnerability to small predators. But size also carries costs. Larger animals require more energy. They reproduce more slowly. They are more vulnerable to environmental disruption. Balance matters. Evolution navigates these trade-offs without awareness, guided only by survival. The fossil record of this time, fragmentary though it is, tells a story of abundance. Shells accumulate on seafloors, burrows crisscross sediments, tracks and trails record movement across ancient surfaces. For the first time, life leaves clear, enduring marks on the planet, not just chemical traces but physical ones. Earth's surface becomes inscribed with activity. Time passes, hundreds of millions of years. Animal life spreads into nearly every marine environment. From sunlit shallows to dark depths, from warm equatorial seas to cooler waters near the poles. No place remains untouched, yet diversity is not evenly distributed. Hotspots of innovation emerge where conditions favor experimentation, regions of fluctuating climate, complex geography, and abundant resources. Here, evolution runs faster. Elsewhere, stability favors persistence. The planet becomes a patchwork of evolutionary tempos. Life's story grows layered and complex. Still, compared to what will come, this world remains quiet. There are no forests rustling in the wind, no calls echoing through air, no eyes gazing across landscapes. Sound, as we know it, has little meaning here. The drama unfolds in silence beneath the waves. The sun continues its steady brightening. Over immense spans of time, this gradual increase in energy will reshape climate, weathering, and ocean chemistry. The planet's long-term balance will shift. Life will be forced to respond again. The future remains open. From these ancient oceans will arise new challenges, new opportunities, and new forms of life that will push complexity even further. But for now, the Earth exists in a rare equilibrium, a living world dominated by animals, yet still confined to the sea. A world where movement, sensation, and interaction are now commonplace. A world that remembers nothing, but carries within it the accumulated consequences of billions of years of change. And as this part comes to a close, the planet continues onward, unknowing and patient, carrying life forward into futures that have not yet imagined themselves. The shoreline does not invite life forward. It is harsh, exposed, and unforgiving. Sunlight strikes without mercy. Water disappears quickly. Temperatures swing wildly between day and night. Gravity presses down without the buoyant support of the sea. For most animals, the land is a place of death, and yet life continues to approach it. Not boldly, not deliberately, but through countless small encounters along the edges of the world where sea and land meet and neither fully dominates. Tides rise and fall as they always have, revealing stretches of rock and sediment twice each day. Pools of seawater are left behind, isolated from the larger ocean. Within them, animals are trapped for hours at a time. Some perish quickly, others endure. Those that endure do not do so by strength or intelligence, but by tolerance. Their bodies lose water more slowly. Their tissues survive brief exposure to air. Their metabolism adjusts to fluctuating oxygen levels. No animal yet chooses the land, but some survive touching it. Over millions of years, survival becomes opportunity. The shoreline becomes a narrow but powerful filter. It selects relentlessly. Every tide removes the unfit. Every retreat leaves behind only those capable of enduring stress. Life adapts not by intention but by persistence. Some animals already possess traits that make this transition slightly less lethal. Thickened outer coverings slow water loss. Internal cavities retain moisture. Respiratory surfaces become more efficient, extracting oxygen from both water and air when necessary. These traits did not evolve for land. They evolved for survival in variable marine environments, but they prove useful here. Along rocky coasts, animals crawl briefly onto exposed surfaces to graze on microbial films. They retreat when water returns. Their excursions are short, cautious, and frequent. The land becomes a place to visit, not yet to inhabit. In shallow waters, plants still simple, still aquatic, begin to grow closer to shore. Photosynthetic life coats rocks, mats of green clinging where waves splash regularly. This new food source is abundant and largely unexploited. Animals that can reach it gain advantage. Selection quietly favors those that linger longer above the waterline. Over time, excursions lengthen. Minutes become hours. Hours become portions of a day. Life presses outward. The sea does not resist. It simply remains what it has always been. The land, too, remains indifferent, but life is patient. Inside animal bodies, subtle changes accumulate. Structures that once served as buoyancy aids or stabilizers in water become useful for support against gravity. Muscular control strengthens. Skeletal elements stiffen. Appendages that once pushed against water now press against solid surfaces. Movement changes. Crawling becomes more deliberate. Weight shifts matter. Balance becomes important. Animals that can distribute their mass more effectively avoid injury and exhaustion. Those that cannot fail quickly. The land tests everything. Respiration becomes the greatest challenge. Water-breathing surfaces collapse in air. Gases exchange differently. Oxygen is abundant, but accessing it without drying out tissues is difficult. Some animals solve this by keeping respiratory surfaces moist within protected cavities. Others rely on diffusion through skin, limited to brief exposures. No solution is perfect, but imperfect solutions suffice. Reproduction remains tied to water. Eggs dry out quickly on land. Larvae require aquatic environments. Life can visit the land, but it cannot yet leave the sea behind. Still, the trend continues. Over millions of years, coastal ecosystems grow more complex. Plants stabilize sediments. Soils begin to form in thin layers. Microbial communities diversify. The land, once sterile, begins to soften. Roots, still primitive, bind particles together. Organic matter accumulates. Nutrients cycle locally rather than washing immediately back into the ocean. The shoreline becomes less hostile. Life notices, not consciously but evolutionarily. Animals venture farther. Some remain in damp environments, riverbanks, floodplains, tidal flats. These places offer moisture, shelter, and food. The boundary between land and sea becomes a gradient rather than a line. Life spreads along it. In these transitional zones, new challenges arise. Gravity demands stronger support. Desiccation demands better water retention. Temperature variation demands physiological flexibility. Animals respond incrementally. Skeletons strengthen, muscles reorganize. Circulatory systems adapt to deliver oxygen more efficiently. Nervous systems refine balance and coordination. Sensory systems adjust. Vision changes as light behaves differently in air. Sound, once a minor factor underwater, becomes more relevant as vibrations travel differently through the atmosphere. The world feels unfamiliar, but unfamiliarity does not stop life, it reshapes it. Plants, too, push farther onto land. Once confined to water, some lineages adapt to withstand exposure. Protective coatings prevent water loss. Structural tissues resist collapse. Reproductive strategies shift toward spores that can survive drying. Vegetation spreads across damp ground. The land begins to green. This changes everything. Plants alter the atmosphere locally. They release oxygen. They moderate temperature. They retain moisture. They create shade. They build habitats. Animals follow. Herbivory feeding on plants emerges on land just as it did in the sea. Mouthparts adapt. Digestive systems adjust to process new materials. Food webs form. The land begins to host its own ecosystems, still fragile, still limited, but unmistakably alive. The silence of the continents begins to fade, not with sound, but with activity. Tracks appear in soft sediments. Burrows pierce the ground. Surfaces bear marks of grazing. Life leaves signatures everywhere it touches. The transition is not sudden. It unfolds over tens of millions of years. Many lineages attempt it. Most fail. Those that succeed do so through a combination of resilience, flexibility, and chance. The first fully terrestrial animals are not large or imposing. They are small, cautious, bound to moisture and shelter. They venture out, then return. Over time, return becomes optional. Reproduction adapts. Eggs gain protective layers. Development shifts to reduce dependence on open water. Life cycles adjust to land-based rhythms. The bond to the sea weakens. The land claims its first permanent inhabitants. Earth changes again. Soils deepen as plant roots penetrate and decay. Nutrients cycle more efficiently. Carbon is drawn down from the atmosphere and stored in biomass and sediments. Climate responds, weather patterns shift subtly. Life reshapes the planet in new ways. The land, once a silent expanse of rock, becomes dynamic. Ecosystems expand inland, following rivers and favorable climates. Forests, still primitive, begin to rise. Vegetation covers vast areas. Animals diversify alongside them. New body plans emerge. Limbs adapt for walking rather than crawling. Joints strengthen. Posture shifts. Senses refine. Smell becomes important in air. Hearing develops as vibrations are detected and interpreted. The world opens, but all of this remains far in the future from the earliest steps onto land. For now, the story is one of hesitation and persistence. Life does not leap from sea to land, it inches, and with each inch, the planet becomes more alive. Earth continues its steady rotation beneath the sun. The moon continues its distant pull. Time continues its quiet work. The oceans still teem with life. The land begins to join them. The age of animals expands beyond the water. The land does not change quickly. It does not suddenly bloom or soften all at once. Even as life begins to spread away from the shoreline, vast stretches of the continents remain empty, exposed, and silent. Wind sweeps across stone. Rain falls and vanishes into dust. Rivers carve channels that run shallow and dry for long stretches of the year, but along their edges, life persists. Plants continue their quiet advance inland, following water wherever it flows. Their presence transforms the ground beneath them. Roots fracture rock, creating space for soil to form. Dead plant matter accumulates, holding moisture and nutrients. Microbial communities flourish in these new environments, further enriching the land. The ground begins to remember life. Animals follow these changes carefully. They do not rush forward. Each step inland carries risk. Water becomes less reliable. Shelter grows scarce. Temperature swings become more severe. Exposure threatens survival at every moment. Those that succeed do so by remaining close to the old world even as they explore the new one. Rivers become corridors of life. Along their banks, animals find moisture, food, and refuge. Floodplains offer soft sediments for burrowing. Vegetation provides cover from heat and desiccation. Life spreads along these narrow ribbons, inching deeper into the continents. As animals spend more time on land, their bodies continue to change. Limbs grow stronger and more jointed, capable of lifting the body clear of the ground. Skeletons adapt to bear weight continuously rather than intermittently. Muscles reorganize to support posture and controlled movement rather than simple propulsion. Balance becomes critical. Without the buoyancy of water, every movement risks collapse. Animals that can coordinate limb placement efficiently move farther and faster. Those that cannot waste energy and fall prey to exhaustion or injury. Selection favors stability. Respiration continues to evolve. Gills are inefficient in air, collapsing under their own weight. In response, internal respiratory structures become more elaborate. Surfaces for gas exchange are protected within the body, kept moist and ventilated through controlled movement. Air becomes a resource rather than a threat. Circulatory systems adapt to deliver oxygen more efficiently throughout the body. Hearts strengthen, blood flow becomes more directed, energy supports greater activity. Animals can now move for longer periods without rest. The land grows more accessible. As terrestrial ecosystems expand, interactions increase. Herbivores feed on plants. Predators follow herbivores. Scavengers consume remains. Food webs form rapidly. The land, once empty, begins to echo the complexity of the seas, yet it remains a different world. Movement on land is slower and more deliberate. Turning requires effort. Acceleration is costly. Gravity enforces caution. Animals adapt their behavior accordingly. Many remain nocturnal, avoiding the heat and dryness of day. Others seek shade beneath plants or retreat into burrows during unfavorable conditions. Behavior becomes tightly linked to environment. Learning, still simple and limited, plays a role. Animals that survive encounters adjust their responses. Routes become familiar. Shelters are remembered. The seeds of spatial awareness emerge. As vegetation spreads, it reshapes climate locally. Forests still young and unlike those of much later eras, moderate temperature, retain moisture, and influence rainfall patterns. The land becomes more hospitable. Animals venture farther. The first fully terrestrial ecosystems stabilize. They are small by later standards, confined to favorable climates and regions. Vast deserts and cold highlands remain largely lifeless, but the trend is unmistakable. Life is claiming the land. Over time, animals diversify to exploit new opportunities. Some specialize in burrowing, spending most of their lives beneath the surface where moisture and temperature are stable. Others become climbers, navigating early plant structures to access food or escape predators. Body plans diversify again. Limbs elongate or shorten. Bodies flatten or rise. Sensory organs adapt to new demands. Vision improves as light behaves differently in air. Distance matters more. Depth perception becomes valuable. Hearing evolves as airborne vibrations gain importance. Ears, simple at first, detect changes in pressure, alerting animals to approaching movement. Smell becomes dominant. Chemical signals travel farther and persist longer in air. Animals use scent to find food, recognize mates, and mark territory. Communication begins to take new forms, not language, not calls as we know them, but chemical traces, vibrations, postures, signals that convey information beyond immediate contact. Life grows expressive. Reproduction adapts further. Eggs gain protective shells or coverings that prevent desiccation. Development becomes more self-contained. Young emerge more fully formed, reducing vulnerability. Life cycles shift, dependence on water lessens. The land becomes home rather than frontier. As animals spread inland, they reshape the planet in profound ways. Burrowing aerates soil. Grazing influences plant growth. Predation controls population balance. Ecosystems regulate themselves more tightly. Feedback loops deepen. Life now plays an active role in shaping landscapes. Soils deepen. Carbon becomes locked into biomass. Atmospheric composition shifts subtly. Earth responds, climate patterns adjust, weathering accelerates. Rivers carry nutrients from land to sea in new quantities. The boundary between land and ocean becomes a conduit of exchange. Life links the two realms. Time continues its patient march. Millions of years pass. Animals grow larger. With abundant vegetation and stable ecosystems, some lineages evolve increased body size. Larger size offers protection from predators and access to new food sources, but it also demands more energy. The balance between size and efficiency shapes evolutionary paths. Predators evolve alongside prey, speed increases, strength increases, strategy emerges. Chase and ambush become common on land, behavior grows more complex. Animals learn routes, recognize hazards, and adjust tactics. The nervous system continues to evolve. Brains, still small by future standards, grow more centralized and capable. Integration improves, coordination becomes smoother, memory extends. Individuals retain information across longer spans. Experience begins to shape behavior more strongly. The land fills with movement, tracks crisscross soft ground. Sounds, still faint, begin to carry through air. Leaves rustle, branches break, footsteps disturb the silence. The world is no longer quiet, yet this is still an early stage. No animal yet dominates the land completely. Ecosystems remain fragile. Climate shifts can erase entire communities. Extinction continues to prune relentlessly, but each loss leaves behind survivors better adapted to the challenges of terrestrial life. The evolutionary engine turns steadily. From these early terrestrial ecosystems will arise forests that stretch across continents, insects that fill the air, reptiles that rule the land, and mammals that inherit the aftermath. All of that lies ahead. For now, the story is one of establishment. Life has left the ocean. It has learned to breathe air, to stand against gravity, to endure dryness and heat. The land, once silent and empty, now hosts living systems of its own. Earth continues its slow rotation beneath the sun. The moon drifts farther away. Time carries everything forward. The land does not settle into permanence. Even as animals and plants spread inland, building the first truly terrestrial ecosystems, the planet continues to change beneath them. Rivers shift their courses, coastlines rise and fall. Mountain ranges lift slowly into the sky, altering winds and rainfall far beyond their slopes. Life must adapt again. Forests expand in favorable regions, their canopies casting shade over the ground below. Moisture lingers longer beneath leaves and branches. Temperatures become more moderate. Beneath this cover, new communities form, animals that rarely see direct sunlight, creatures adapted to dimness and shelter. The forest floor becomes layered with life. Small animals scurry through leaf litter, feeding on decaying plant matter and the organisms it supports. Others climb trunks and stems, exploring vertical space that did not exist before. Predators follow, learning to move quietly, to wait, to strike with precision. The air begins to matter more. Smells travel on currents, carrying information across distance. Sounds propagate through open spaces, reflecting off surfaces, announcing presence or danger. Life begins to communicate in new ways, not with words, but with signals that persist beyond immediate contact. The world grows connected. As forests spread, they transform the planet's chemistry. Vast amounts of carbon are drawn from the atmosphere and locked into wood and soil. Oxygen remains abundant. The climate stabilizes in some regions while others become more extreme. Life responds to both. In drier regions, plants adapt to conserve water. Their leaves shrink or harden, their roots dive deeper. Animals follow suit, evolving behaviors and physiologies that allow survival with less moisture. Burrowing becomes more common. Activity shifts to cooler hours. Water becomes precious. In wetter regions, abundance allows specialization. Animals evolve to feed on specific plants or prey. Niches multiply. Competition intensifies. Diversity increases. The land now hosts ecosystems as complex as those of the sea, and yet the ocean remains vital. Many animals still depend on aquatic environments for parts of their life cycles. Rivers and wetlands connect land and sea, carrying nutrients and organisms between realms. Life remains intertwined. Time continues. Hundreds of millions of years pass. The continents drift apart and collide. Supercontinents form and break. Ocean currents rearrange themselves, redistributing heat and moisture across the globe. These changes reshape climates dramatically. Some regions become lush and warm, others cool and dry. Ice returns periodically, advancing across high latitudes and retreating again. Each shift challenges life. Mass extinctions strike, wiping out dominant groups and reshaping ecosystems. Causes vary: volcanic eruptions, climate swings, changes in sea level, but the effect is consistent. Life is reduced. Then it recovers. Survivors radiate into empty niches, often evolving rapidly in the aftermath. New forms appear, old patterns dissolve, the story repeats. On land, animals grow more sophisticated, limbs refine, posture improves, movement becomes more efficient. Some lineages evolve to run swiftly across open ground. Others remain slow and deliberate, relying on armor or concealment. Predators and prey co-evolve in intricate dances. Speed meets stealth, strength meets strategy. Sensory systems sharpen, vision becomes more acute, eyes move forward, allowing depth perception. Hearing improves as ears adapt to detect subtle differences in sound direction and frequency. Smell remains dominant, guiding animals through invisible chemical landscapes. Brains grow larger relative to body size, not suddenly, but steadily. Neural circuits become more complex, memory extends, learning plays a greater role in survival. Animals that can adapt behavior within their lifetimes gain advantage. Experience begins to matter. The world becomes a place not just of instinct, but of adjustment. Social behavior emerges. Some animals benefit from staying together. Groups offer protection, improve foraging efficiency, and increase reproductive success. Communication within these groups evolves. Gestures, vocalizations, sense, coordination appears. Not culture as humans know it, but something foundational. Life experiments with cooperation. The land fills with movement and interaction. From above, Earth would appear transformed. Where once continents were barren, now vast regions are green. Rivers thread through forests. Plains stretch beneath shifting skies. Ice caps wax and wane at the poles. The planet breathes. Life has become a force shaping Earth's surface and atmosphere as profoundly as tectonics or climate. and still change continues. New lineages rise, old ones fall. Among the animals, some begin to dominate the land. Large-bodied forms appear, supported by strong skeletons and efficient respiration. They move deliberately, consuming vast quantities of vegetation or hunting other animals. The land supports giants, but giants are vulnerable. They require stability. They struggle during rapid environmental change. Smaller animals persist through upheaval, hiding, adapting, surviving where larger forms cannot. The balance shifts repeatedly. Life never settles for long. As eras pass, ecosystems grow more complex, more layered, more interdependent. Insects, small, numerous, and adaptable, become increasingly influential. They pollinate plants, decompose matter, serve as food for countless other animals. The air begins to fill with motion. Wings appear. Flight transforms the planet in ways no earlier adaptation ever did. Animals take to the sky, escaping gravity's hold and accessing new niches. Plants benefit as well, spreading spores and seeds farther than ever before. The three-dimensional world expands. Land, sea, and air become interconnected arenas of life. With flight comes new challenges: navigation, balance, energy management. Animals meet them. The pace of life accelerates. Generation times shorten. Evolution speeds up in some lineages. The world feels busy. Yet beneath all of this, the planet remains patient. Mountains rise and erode. Continents drift. The sun grows brighter. Moon drifts farther away. Life rides these changes, reshaping itself again and again. Eventually, mammals emerge, small at first, warm-blooded, nocturnal. They survive in the shadows of larger, dominant reptiles, biding time. Their brains grow larger, their senses sharpen, their behaviors grow flexible. They remember, they learn, they adapt quickly. When catastrophe strikes, when the world changes abruptly, these traits matter. The dominant giants fall, mammals rise, forests change, grasslands spread. New ecosystems emerge, animals adapt yet again. Among mammals, some lineages evolve enhanced cognition. Social bonds deepen, communication becomes richer, memory extends further into the past and anticipation into the future. The world begins to be experienced not just moment to moment, but across time. Eventually, after billions of years of preparation, creatures appear that can reflect. They look at their surroundings and recognize patterns. They remember seasons. They anticipate outcomes. They wonder. These creatures are not inevitable. They are the result of countless contingencies layered atop one another, stretching back to a silent planet with no animals at all. The journey from lifeless rock to reflective mind is long, fragile, and improbable. And yet, here it is. Earth carries within it minds capable of asking how it all began, capable of imagining deep time, capable of telling stories about a world that existed long before anyone was there to witness it. This is not the end of the story. The planet will continue to change. Life will continue to adapt. Minds will rise and fall. But for now, we pause. We rest at the edge of the present, looking back across billions of years to a time when Earth waited in silence, alive but unawake. A billion years with no animals, a world preparing itself slowly and patiently for everything that would come next. And as this part fades, the planet continues onward, turning beneath the stars, carrying life forward into futures still unknown, still unwritten, still waiting to awaken. The story does not end with awareness. It never truly ends. Even now, as minds capable of reflection appear upon the surface of the planet, Earth continues its slow, indifferent movement through space. The sun rises and sets, seasons shift, continents drift. The deep processes that shaped a lifeless world into a living one continue, unchanged in their patience. What changes is perspective. For the first time, life begins to look back. The minds that emerge late in this long history are fragile things. They exist for moments compared to the age of the planet. They flicker into being, carry memories for a brief span, and vanish again. Yet within those moments, they compress billions of years into stories, symbols, and questions. They ask how it began. They imagine worlds with no animals, no sound, no witness. They try to feel the silence, but Earth does not remember that silence. The planet has no memory of waiting. It carries no nostalgia for the age of microbes or the first stirring of animals in ancient seas. It does not mourn extinctions or celebrate new beginnings. To Earth, all moments are equal, each one another step in an endless unfolding. Life, however, remembers in fragments. It remembers through genes passed forward, through structures refined by survival, through instincts shaped by environments long vanished. Every living body carries echoes of that ancient world. The chemistry inside cells still follows rules set billions of years ago. The dependence on oxygen traces back to microbes that once poisoned their own planet. The nervous systems that allow sensation and thought are built upon pathways first assembled when movement became possible beneath the waves. Even the most complex minds are layered atop ancient foundations. Inside every breath there is history. Inside every heartbeat there is deep time. The age of animals, once unimaginable, now feels ordinary to those who inhabit it. Predation, cooperation, learning, memory, these are now taken for granted as if they were always present. But they were not. For most of Earth's existence, nothing moved with purpose. Nothing sensed the world. Nothing feared or desired. There was only chemistry, cycling endlessly through rock, water, and air. Life emerged not because the planet intended it, but because conditions allowed it. Animals arose not because life sought complexity, but because energy, time, and chance aligned. Awareness is not the goal of evolution. It is a consequence, and like all consequences, it is temporary. The same forces that once erased entire microbial worlds, that later wiped out vast animal lineages, remain at work. Climate shifts. Asteroids wander, volcanic provinces awaken. Continents rearrange themselves without regard for what lives upon them. Life responds, it always has. Minds respond too, adapting behavior, reshaping environments, altering the planet in new and powerful ways. For the first time, a species arises that can change Earth faster than geological processes alone. Forests fall, atmospheres shift, rivers are redirected. The chemistry of the planet begins to move at a pace once reserved for catastrophe. This too becomes part of the story. The planet absorbs it. It always does. Whether minds persist or vanish, Earth will continue. Long after current species are gone, long after cities crumble and languages fade, the planet will remain, turning beneath a sun that grows ever brighter. Eventually, even animals may disappear. As the sun ages, its energy output will increase. Oceans will evaporate. Atmospheres will thin. The surface will grow hostile once more. The conditions that allowed life to flourish will pass. Earth will return in a way to silence. Not the same silence as before, because nothing ever truly returns, but a new stillness shaped by everything that came before. Rocks will remember. The planet's crust will hold traces of life, fossilized remains, altered minerals, chemical signatures that speak of biology long gone, but there will be no one to read them, unless life begins again. Unless somewhere else under different stars the same quiet processes unfold, dust gathering into planets, water condensing, chemistry repeating itself long enough to stumble into persistence. If that happens, the story will begin again, not exactly the same, but familiar. A world without animals, a world that waits, time passing without witness. Oceans rising and falling against empty shores, lightning cracking through skies no eyes will ever see. And somewhere deep within that silence, molecules drifting together, forming patterns that last just a little longer than the rest. Life beginning again, not because it must, but because it can. This is the deeper truth of Earth's long history. Not progress, not destiny, but possibility. The planet did not aim for animals. It did not aim for minds. It created conditions. Time did the rest. And so, as this part draws to a close, we return once more to that ancient perspective, to the Earth before experience, before awareness, before sound. A planet turning quietly beneath a young sun, oceans without movement beyond waves, skies without breath, a billion years with no animals, not empty, not barren, but waiting. Waiting in the only way a planet can, by continuing to exist, moment after moment, change after change, carrying within it the potential for worlds yet unimagined. And even now, as you listen, that waiting continues, somewhere, sometime, under stars that have not yet risen. The silence has not ended, it has only moved elsewhere. The silence, once broken, never truly disappears, it retreats, it waits. It gathers at the edges of awareness. Even now, long after animals learn to move, to sense, to remember, vast portions of the universe remain exactly as Earth once was, unobserved, untouched by experience, unfolding slowly without witness. And Earth itself still carries that ancient stillness within it. Beneath forests and cities, beneath oceans busy with life, deep layers of the planet remain as they always were, rock cooling slowly, minerals shifting imperceptibly, pressure building and releasing without sound or intention. These regions do not know life exists above them. They operate by the same rules that governed Earth before the first cell ever formed. In this way, the world with no animals never fully vanished. It became hidden. Life, for all its movement and noise, occupies only a thin skin on the surface of the planet. A fragile layer measured in kilometers atop a world thousands of kilometers deep. Below that skin, the ancient Earth persists, quiet, indifferent, and slow. Time there feels different. Processes unfold over millions of years without urgency. Mountains rise because pressure demands release. Plates drift because heat must escape. Nothing accelerates, nothing pauses. The planet does not hurry. Life does. That difference, the contrast between geological patience and biological urgency, shapes everything that follows. Animals experience time as something that moves, as something that can be lost, wasted, feared. They live within narrow windows, driven by needs that demand action now. Eat now, move now, escape now. But the Earth that once hosted a billion years with no animals does not share that perspective. To the planet, urgency does not exist. Extinction is not tragedy. Emergence is not triumph. They are events no different from eruptions or impacts. Life experiences itself as central. The planet does not. This tension grows sharper as minds evolve. The creatures capable of reflection begin to see themselves as participants in a story. They trace beginnings, they imagine endings, they place themselves within narratives that stretch backward into deep time and forward into imagined futures. They name eras, they mark transitions, they divide the planet's history into chapters. But these divisions exist only in thought. Earth never turned a page. When animals first appeared, the planet did not recognize a new age. When forests spread across continents, there was no announcement. When minds capable of wonder emerged, nothing in the rotation of the planet changed. The sun continued to rise. The moon continued to pull. The oceans continued their endless motion. And yet something truly new had occurred. For the first time, the universe was being noticed by something that arose within it. That noticing, fragile, fleeting, rare, changed the meaning of silence. Before animals, silence simply existed. After awareness, silence became something that could be remembered and missed. Minds imagined the ancient Earth as lonely, empty, waiting. But loneliness requires longing, and the ancient earth had none. It was complete in its own way, full of motion, chemistry, and change, but empty of concern. Only later would silence acquire emotional weight. Only later would stillness feel like absence. This is one of the quiet ironies of life's emergence. Awareness creates meaning, but also creates loss. Once something can be experienced, it can also be gone. The billion years with no animals did not know they were missing anything. The world that followed did. As life continued forward, awareness deepened, memory lengthened, anticipation grew. Animals began to carry not only their present sensations, but traces of past experiences and expectations of what might come next. The present moment thickened, layered with echoes and projections. Time became psychological, and with that shift, silence transformed. It was no longer simply the absence of sound. It became a space where thought could wander, where fear could grow, where wonder could unfold. The ancient silence had been neutral. The new silence was charged. Even now, in moments of stillness, minds brush against that older world without knowing it. When sound fades, when motion slows, when attention drifts inward, something ancient stirs, not memory exactly, but resonance. A sense of vastness, a sense of time stretching far beyond any single life. These moments echo the age before animals, when nothing needed to respond, when nothing needed to hurry. In this way, the ancient earth still speaks, not through words, but through scale. It reminds life how small it is, how temporary, how improbable, and how deeply connected it remains to a past it never lived. Every animal body is a monument to that past. Bones trace back to seas where support first mattered. Lungs echo the challenge of extracting oxygen from air rather than water. Brains carry circuitry built upon pathways that once merely coordinated movement in soft-bodied creatures drifting through shallow oceans. Even emotions have roots there. Fear is an inheritance of predation. Curiosity emerges from exploration. Social bonds arise from cooperation that once improved survival. Nothing about life is separate from its deep history, not even thought. And so when minds imagine a world without animals, they are not imagining something foreign. They are imagining their own foundation, a time when the rules that shaped them were still assembling. A time when the planet was learning how to host experience without knowing it was doing so. That learning took billions of years. It required stability without stagnation, change without collapse, energy without excess. It required oceans that persisted long enough for chemistry to repeat itself until it stumbled into life. It required an atmosphere that shifted slowly enough to allow adaptation. It required time, vast, patient time, and even then nothing was guaranteed. Life could have failed, animals might never have emerged, complexity could have stalled. The world could have remained microbial forever. That it did not is not evidence of destiny, it is evidence of contingency. Everything that followed depended on chance layered upon chance, filtered by conditions that did not care what emerged from them. This understanding humbles. It places life not at the center of the universe, but at a rare intersection of circumstances. The billion years with no animals were not a prelude written for our benefit. They were simply what happened. And what happened next was not promised. Even now, nothing about the future is certain. Life will change again. Silence will return in new forms. Awareness may fade, but the planet will persist, reshaping itself long after current stories are forgotten. This is not a bleak thought. It is a quiet one. It reminds us that meaning arises locally, briefly, and beautifully within vast systems that do not require it. The ancient earth did not need animals to be whole. But animals needed the ancient earth to exist at all. And so, as this part draws to a close, we rest once more in that deep perspective, not at the height of complexity, not at the edge of the present, but somewhere far behind it all. A young planet, a dimmer sun, oceans forming beneath toxic skies, no movement driven by desire, no eyes to see, no minds to wonder, just time unfolding patiently, a billion years with no animals, not as absence, but as possibility. And from that possibility, everything else quietly followed. Before we leave this story behind, we return one last time to the beginning, not to add anything new, but to see it clearly. Imagine the earth again as it once was, no forests, no movement driven by hunger or fear, no eyes opening beneath the sea, just a planet turning quietly beneath a young sun. For most of its existence, Earth did not host animals, it did not host minds, it did not host experience. It existed as matter and motion, fire cooling into stone, water gathering into oceans, gases rising and falling through an alien sky. This was not a pause before life, it was life's foundation. A billion years with no animals was not an empty age, it was an age of preparation. An age where chemistry learned how to persist, where the planet learned how to stabilize, where time itself did the slow work no mind could ever manage. Nothing rushed, nothing watched. The oceans formed and reformed. Continents drifted without destination. The moon pulled tides across empty shores. Lightning cracked through skies no ears could hear, and still something was happening. Molecules collided. Patterns repeated, structures lasted just a little longer than the rest. Life emerged not as intention, but as inevitability given enough time and enough stability. Single cells dominated the planet for longer than animals have existed even now. They reshaped the atmosphere, altered the oceans, and transformed the surface of the world, quietly, blindly, without awareness. They made oxygen, they changed the sky, they prepared the way, and still nothing moved with purpose. Only after unimaginable stretches of time did life begin to respond to light, to pressure, to chemistry. Movement followed, sensation followed, bodies took shape, nervous systems formed. The first animals stirred beneath ancient seas. The silence thinned, not all at once, but enough. From that moment onward, the planet would never again be truly without animals. Even when extinctions came, even when worlds collapsed and rebuilt, movement and experience would always return. The earth crossed a threshold, and everything that followed, forests, predators, flight, mines, rests upon that crossing. The animals that walk the land today, the creatures that swim and fly, the minds capable of reflection and wonder, all carry the imprint of that ancient world within them. Every breath traces back to oxygen released by microbes that never knew what they were creating. Every thought rests on neural pathways built from systems that once only coordinated simple contractions in the dark. Every moment of awareness stands on a foundation laid during a time when awareness did not yet exist. This is the quiet truth of deep time. Nothing about us was inevitable. The planet did not aim for animals. It did not aim for intelligence. It did not aim for meaning. It created conditions, time did the rest, and time is still doing its work. Long after current species are gone, long after familiar landscapes have vanished, Earth will continue to change. Silence will return in new forms. Life may fade or begin again in ways we cannot imagine. The universe does not promise continuity, only possibility. And that is what makes this story matter, not because it leads to us, but because it did not have to. A billion years with no animals was not waiting for anything. It was simply being, and from that being, everything else quietly emerged. If this journey through deep time helped you slow down, reflect, or feel the vastness of Earth's past, I invite you to stay with this channel. Subscribe if you enjoy quiet history like this, stories meant not to rush but to drift. Leave a comment and tell us where you're watching from, what part of the world you're listening in from as this ancient planet continues to turn. And until next time, rest easy. And remember how long the world waited before anything could watch it do so.